Hi there, I'm Hao, and this is just another video of me solving random code problem. So we need to count a good node in the binary tree. A good node is a node that from the root to the current node, there is no value that is larger than the value of the current node, right? So the root is always a good node because it is the first node. So of course there's no previous node, right? So the root node is always a good node. 4 is good because 3 is smaller than 4. Right? 5 is good because 3 and 4 are smaller than 5. Right? 1 is not a good node because they contains a larger value. Right? 1 here is not a good node because 1 is smaller than 3. Right? Mm. 3 is a good node because the path from the root to the current node contains no value that is larger than the current node. Okay. So we can keep track of the current maximum, right? We start out at negative infinity, right? And we can keep track of the good node, right? So if the current value is larger than the current max, right, we increment the good node by 1 and keep going, right, using a depth first search, right? And as you iterate, we're gonna pass in the maximum, right, the next maximum, right, which is between the current node value and the current maximum. In this case, 3 is larger, right? 1, right? 1 is smaller than 3, right? So the path from the root to 1 contains a value that is larger than the current node, right, which is 1, right? So it is smaller than the max, so we don't care. We keep going here, right? So the maximum between 3 and 1 gonna be 3, right? So 3 is larger than or equal to 3, right? So we increase the good node by 1. So over here, the max is 3. 4 is larger than 3, so we increase the good node, right? We pass in the maximum between the two, so 4. So 1 is smaller than 4, right? So we ignore. And now we have 5. 5, sorry, this is the max, right? 5 is larger than 4, so we increase the good node by 1. So we have 4 good node. Okay. Because we need to iterate over every single node, so that is O of M runtime. Okay, so we need BFF for the node and the max. Okay, so if node dot value is larger than or equal to the max, then we can increase the good node by 1, right? If there's no dot left, we keep counting, right? So the max, the next max is going to be the max within the max, and then the current node value. Okay. Same thing for the right side. We find a good node for the depth first search. We start out at negative infinity, so it's only pass for the first comparison, and we return the good node at the end. Okay, it worked. Thank you for watching.